Hello everyone, my name is Cole, and Chris and I hammer forged a blade for our project. In our presentation, we're going to get into the details of the project proposal, what was planned, and then the process we went through as we worked on our project. So hammer forging as a process is pretty old school compared to a lot of the other methods we've learned, but it still does what it'll need to do. We decided to hammer forge because we thought it would be slightly more complicated than some other processes like 3D printing, and we wanted to get a little bit of experiential learning under our belts. Some of the complications that we come across were of little concern, and we're going to get into that more in just a little bit. But the methodology behind hammer forging is pretty straightforward. You're going to need a forge, your desired material, an anvil to hammer the steel over, a hammer, and some tongs. So this is where we get more into the problems that we had encountered. Any project is bound to have some bumps and bruises along the way, but these are mostly just what we had come across. Because we had decided to build a prototype, most of the work would have had to have been done in person. And this basically meant that a large majority of the project needed to be done before we left for break, so time management was pretty important. Additionally, recording footage needed to be completed along the same timeline, so a lot of our material was provided with a voiceover to account for not wanting to narrate as we forged the blade. This would have led to unnecessary distractions and more work that would have been front-loaded for our project. And lastly, because the project involves hot metal and necessary care, safety is going to be a large concern. We didn't necessarily have issues with safety per se, but it was of critical importance that our well-being was considered at all times, and that meant wearing proper equipment and handling with utmost caution. So in this slide, we've detailed a couple of the safety concerns, mainly goggles, long sleeves, any type of protective clothing, and closed-toed shoes while being in a remote location, because when we're using the grinder, some very small powdery specks of metal can fly up, but as long as you have the proper wear for those safety considerations, then you're fine, which is what we ended up doing. So the rundown for our project required 5 major steps. We needed to acquire the material, cut it down in the grinder, heat the material, hammer the material into place, and then file down the blade to reach the desired quality. And then our next couple of slides are going to detail this process with some explanation as well as some footage of us working on the blade, which is really what people are looking for there. So,
our first step was to choose our material. For our project, we chose mild carbon steel. This was because it was abundant in our area and it was fairly cheap. There are other options, like high carbon steel, which is more ideal for blacksmithing. High carbon steel balances ductility and strength and has a good wear resistance. Mild carbon steel, like the one we used, is less strong but cheap and easy to shape. The surface hardness can be increased through carburization. The first step was preliminary cutting. During this step, we used a hand grinder to cut out the profile of our blade. The second step is in the forging process uses a furnace to heat the workpiece above its recrystallization temperature. For mild steel, this temperature is 2,150 degrees Fahrenheit. Hammering the piece is a very brutal process, but it is an important step in forging. Once the steel is heated past its recrystallization temperature, the workpiece is deformed plastically into shape using a hammer. This can be seen in the following videos. Cutting the piece to shape seems redundant. However, the hammering process is necessary, or After the hammering process, it is necessary to cut out the final desired profile for your blade. It is important to note that it is easy to begin shaping your bevel to your knife. This step should be reserved for the filing process later on. Also, during this time, you can overheat your workpiece, creating a number of heat-affected zones affecting the material properties in that area. Heat-affected zones can be seen in the top right-hand corner. Filing adds the finishing touches to the blade to ensure proper quality. Using a filing jig allows the blacksmith to practice uniform filing strokes and allows for adjustments in the filing angle. A hand grinder can be used to speed up the process, but it is typically done by hand. Our group did not heat treat our blade. However, the process goes like this. Heat treatment softens the workpiece using extreme temperatures. Once the workpiece reaches the heat treatment temperature, roughly 2400 degrees Fahrenheit, the workpiece is then taken from the furnace and quenched in oil and water. This is our final product. After polishing and grinding, our group removed most of the hammer marks and dark layers. We made a handle from a Dremel 3D printer. Lessons learned. Mild carbon versus high carbon steel. Mild carbon steel is less strong but cheap and easy to shape. High carbon steel offers a balance of ductility and strength and good wear resistance. Hammering and forming the bevel. Hammering is difficult and it takes time to master. It is important to keep your hammer square to limit hammer marks. Also, different size hammers can be used for different applications. Time needed to fully form the blade to its fullest quality. Forging takes a very long time. Process for the grinder. Grinder is a friend, but it should be used modestly. Next, we will show you our video montage.